Alright, in this section we are going to talk about upper motor neurons. So these are the ones going from the cerebral cortex, and they're going to synapse with the spinal interneurons to eventually get to the lower motor neurons, sending those descending messages. So there are two different upper motor neuron groups that we're going to talk about, and we're going to talk about the medial upper motor neurons and the lateral upper motor neurons. So there's a slide in the PowerPoint that has two diagrams from the book. One, the first one showing the medial ones, the one on the left, and the one on the right is showing the lateral. They're also in the module, and I'll go over them a bit. But the medial upper motor neurons, they are the ones that are responsible for postural and gross motor movements, so the large movements. So the upper motor neuron activity that controls posture and gross movements usually occurs automatically without conscious effort. So the medial upper motor neuron activity can occur before you're even consciously aware of a stimulus. So that the example is the loud noise occurs behind you and your eyes and face turn towards the sound before you're even consciously aware of the auditory stimulus. So it happens so fast, and it's on that unconscious level. You start the motor pathway before you're even consciously aware of the stimulus that caused it, which is kind of cool that we can react that fast. So there are 4 different tracks in the medial upper motor neurons. The first one is the reticulospinal tract. So just like the sensory tracks, the motor tracks, they tell you, their name tells you where they go to and from. And the fun thing, well, I don't know how fun it is, but the nice thing about the upper motor neuron tracks, they all end in spinal. Because all of the upper motor neuron tracks go from somewhere in the brain to the spine. So the reticulospinal, the vestibulospinal, the corticospinal, and it tells you exactly where it goes to and from. You gotta love that. So the reticulospinal, it goes from the reticular activating system to the spine. And it facilitates bilateral lower motor neurons innervating postural and gross limb movement muscles throughout the body. Okay? So that's that. It's the stuff that's going on unconsciously. We don't have to think about our gross limb movement and our postural movement all the time. And a lot of times we respond quicker than we're even aware of a stimulus. Okay? The medial vestibulospinal tracts. The vestibular system has a lot to do with head movement and head positioning. So the medial vestibulospinal tracts receive information about head movement from the vestibular apparatus, and it sends it down to those postural muscles. And so our vestibular system has a big effect on our postural muscles. The lateral vestibulospinal tract responds to gravity information from the vestibular apparatus. So that's all the information we're getting just from living on a planet with a gravity field. The medial corticospinal tract, so corticospinal goes from the cortex, the cerebral cortex, to the spine. It's the direct connection from the cerebral cortex to the spinal cord. Okay, so all of our decision-making stuff is coming through the medial corticospinal tract. Our conscious decision-making stuff. Okay, so those are the medial upper motor neuron tracts. The lateral upper motor neurons, so the medial ones, they do the gross movements and the postural movements. The lateral upper motor neurons, they activate individual muscles independently. They perform what's called fractionation, and that is essential for normal movements of the hands. So without fractionation, the fingers and thumb would act as a single unit instead of being able to act individually like when we type on a keyboard. So it's the difference between picking up a water bottle, they're acting all as a single unit, they're doing the same thing, versus keyboarding where they're all doing something different. So the lateral upper motor neurons, they handle that fractionation. So the big tract for the lateral neurons is the lateral corticospinal tract, It fractionates movement by activating inhibitory neurons to prevent unwanted muscles from contracting. It's the most important pathway in controlling voluntary movements. So the interesting thing is you have to have that inhibition to prevent unwanted muscles from contracting. And we'll see in chapter 11 when we talk about the cerebrum and the basal ganglia. The basal ganglia and the cerebrum control a lot of those inhibitory neurons. And so when we lack that inhibition, you get things like tremors in Parkinson's and involuntary movements in something like Huntington's. So by activating those inhibitory neurons, it prevents unwanted muscles from contracting and keeps us from doing motions we don't want to do, and that allows us to perform the motions we do want to do. It's the most important thing controlling voluntary movements. So the lateral corticospinal tract, that is the one that's affected in ALS or Lou Gehrig's disease. That's what Stephen Hawking has. He has a rare form of it where he has more longevity. A lot of people with ALS, it's 3 or 4 years from the time they're diagnosed until their breathing pathways stop working and they cannot live without a respirator anymore. So the lateral, so ALS stands for amyotropic lateral sclerosis. It affects these lateral corticospinal tracts. So the lateral corticospinal fibers arise in the primary motor, premotor, and supplementary motor cortex in the cerebral cortex. Okay, it talks about the location of the primary motor cortex, and we're going to talk more about that in the cerebrum chapter. So I'm not going to test you on this or anything, but it's located anterior to the central sulcus in the precentral gyrus. So the sensory association areas are just posterior to that. So each area of the cerebral cortex has its own function, and the primary motor cortex is its own little place. So there's some pictures in the book that are showing the individual tracts, and you know, I certainly don't expect you to memorize these or anything, but one thing that is important to know is that unlike the sensory neurons, which cross over at different points, the sensory tracts cross over at different points in the spinal cord, the motor tracts, they all cross over in the brain stem. So no matter where a spinal cord injury happens, it's going to happen after the crossover, so the motor effects are always going to be on the contralateral side if you have a hemisection of the cord. So I mean, just know that the descending motor tracts all cross over in the brainstem. So none of them cross over lower like the sensory tracts. So we're not really going to talk about the nonspecific. So we're going to, let me just talk about a couple other things with the upper motor neurons. So I just have the information arranged a little bit differently in the module. So just remember, the upper motor neurons provide all of the motor signals from the brain to the spinal cord. The medial upper motor neurons control posture and gross movements, and that's usually occurring automatically. The lateral upper motor neurons control limb flexion and fine movements, and they provide fractionation of movements, and that is most of the voluntary movements in our body. So medial is the postural and the gross movements, lateral is the fine movements and the fractionation, and it's most of the voluntary movement. So there's a nice little 5-minute video that talks about the difference between upper motor neurons and lower motor neurons, and that's kind of a nice little synopsis. It's one of those ones where they're drawing as they talk. And it also discusses the signs of motor neuron lesions, which we'll talk about in the next part of the lecture. So the nonspecific upper motor neurons, I said we're not going to talk too much about them, but they they're tracts that descend from a certain area of the brainstem, and they enhance the activity of interneurons and lower motor neurons in the spinal cord. And that's all we're going to say about that. So they are focused more on what's going on with the interneurons and the lower motor neurons by enhancing that activity. So I'm going to wrap up this section, and then we'll talk about signs of motor neuron lesions. And we will see that a lot of them have to do with where the lesion is and what kind of effects you have from it.